Hey, thank you all for inviting me. This is quite a treat to meet other people from around the state. We all get into our own silos in our own cities, and sometimes it's hard to meet the local folks. So it's really cool to get a chance to. There's my contact information. If anything in this is interesting or completely uninteresting, feel free to let me know about it. And I'd love to hear some feedback on what you guys are doing, what you all are doing in your organization. Everything we're going to talk about is completely forward-thinking. 3 to 5 years is probably realistic, but there are some solid use cases today. Please stop me, questions, whatever. It's always more fun to be interactive. I know it's getting recorded, and it's horrifying to think about somebody watching it on TV. So, software-defined networking. Today in the industry, we have one brush to paint all networks. If you're a service provider, if you're an enterprise, you run a hyperscale data center, a hospital, it transcends into all the verticals. We build the same network everywhere. We've got limited sets of tools that we can provision and deprovision networks with. And so the problem that being is there is no customization to start fitting your business strategy and business goals. So particularly today, that pain point is in the hyperscale data center. VLAN limitations, flexibility, being able to move a machine from one physical place to another and not worry to have these constraints of IP addressing. So certainly do propose that we start thinking about having more tools to have more purpose-built networks as opposed to one brush to paint them all. So I've had this slide in this deck for a while, and I do need to preface this is the first time I've given this deck, so if I look at this slide and I'm surprised, I apologize. I'm almost to the point where we can start pulling this out. A year and a half, 2 years ago, this was all kind of shrugged off as, those people out of academia or silly researchers doing their thing. We're really starting to see some movement in it. Vendors are slowly grinding to a halt on some of the legacy thought and starting to head in another direction. So Martin Casada, one of the founders of Nasira, he describes the data center as this ability to decompose storage, compute, and network into these small, consumable chunks. So storage and compute is there. We've got VM farms that for capacity planning and scaling out and up, it's pretty straightforward. You're modularly adding on, either scaling it out or scaling it up. Network is nothing like that at all. You still typically tap on your keyboards. And so what kind of happened is we got stuck with this giant, half the slide, there we go. So we got stuck with these bag of protocols. So when this all started, IP was pretty elegant, great solution. But then as more problems came along from the inflexible that we didn't grow. So we started putting all these new protocols in there, and so we just kind of start doing this complexity horizontally instead of building abstraction layers that we see in operating systems and applications. So security is really interesting. I was doing some research this week just in preparation, and there is not a lot out there about security and software-defined networking. And this is a pretty nebulous thing still to this day, and it's still kind of going through getting to find exactly what it is. But so the problem, the overarching problem, in my opinion, of what SDN can solve is this problem of the edge. So we ingest traffic into the edge of our networks, whether it's from another autonomous system or whether it's from an end user. And this idea of classification, so you guys, identity management, knowing what traffic is coming into your network, it's a really hard thing to do because we're kind of left with this still primitive construct that doesn't allow us to do a whole lot of anything. And when we do it, it normally comes in the form of a new encapsulation or a new protocol. So all these things are problems. We've got security policy is a problem. Multi-tenancy is a big problem. How do you classify different tenants, whether it's in a data center, whether it's regulatory. I design and operate a hospital network and a university network at the University of Kentucky. So what that, we see about everything. So we've got this really wide open network on the campus side for research, and then we've got a hospital that, is under HIPAA, and then the overarching compliance is actually PCI, which you guys are probably painfully aware of. So that multi-tenancy problem is not just for hyperscale data centers. That's for, we all run multi-tenant environments, whether you're an enterprise with different VUs. And then QoS, whenever anybody comes in and says, what's your QoS policy, I like laugh, because where's the army of people that are going to go out and manually type in these distributed BIOSes across, an enterprise to maintain a flexible QoS policy. And then cost. Cost is a big part of this, but I think it's the least interesting part of it. So along the cost thread, what changed? There's a couple things that changed. So there's too many words in this slide. I'm actually going to start trimming it down, but just that's for later reading. But the commoditization of hardware is the main thing that came along. So what that does is we've got this idea that when people used to do ASICs, so when we grew up on ASICs and network devices that are purpose-built to do one thing in hardware. So what happened over the past few years is those ASICs became generally available through Broadcom and Marvell, and so there's a handful of ASIC vendors that are now building these things. And a lot of people are just taking off-the-shelf ASICs and putting them into their own hardware that allows them to build. So this is a picture of Google's Pluto switch. So what they did is took this off the shelf, they cobbled together a switch, and now that's what they're running their SDN deployment. So these aren't new ideas. We've got VM farms today, we've got abstraction layers put in place, and so these same kind of computer science concepts need to start happening in networking to continue to scale. So abstraction is probably one of the heart of programming, computer science. What that allows to do is obfuscate the complexity that's underlying and begin building more scalable solutions through modulating. So when we write code, we write it modularly. That's how we scale out to millions of lines of code. That doesn't apply to you stay on this linear cost model. Every time you put in a new box into the network, there is no scale to it. So just sorry, I just got a fixed slide in there. I think I fixed it, but I didn't pull out the fixed slide. So just a quick kind of, so at the heart of something like Overblow. So Overblow is just a wire protocol. Overblow is not SDN, I'm sure that's clear. But what is there, whether it's going to be MPLS, whatever that signaling protocol is going to be in that wire protocol, the ability to have, so on a typical switch today, you have, you're looking at a fixed set of fields. So you've got layer 2 through 4 is pretty much where networking operates. So within each one of those, you've got about 8 to 10 fields that you can put in data into, and then something's going to read it and spit it back out. So firewalls typically are going to look at layer 3 and 4. Switches are typically going to look at layer 2. Routers are typically going to look at layer 2 and 3. So the potential here is it's almost just this canvas, this blank canvas that you can say, well, I want to use the switch that I bought, and I want to be able to leverage any of those fields in there. So this is probably at the heart of the disruption in the industry, is because instead of paying $500,000 for a 50 gig line rate firewall, theoretically, if the architecture begins to change, we expect as customers for that to change, we can now start leveraging those for multiple purposes instead of just that. And then the other interesting thing is, it's whatever you want to do with it, right? So, here on a typical switch, I either flood or I send out one other port. Well, what if I want to send it out packet ports? I want to send that to an IDS. Well, now you can start doing that. So it's just kind of breaking down the constraints of existing protocols. So, just real quick, so when you start hearing about Overblow, you're going to hear about PCAM. So you've got two basic content addressable memory lookups. You've got a binary and you've got a ternary. The main difference is, if there are any programmers in here, if you've ever done a binary tree lookup, it begins breaking down branches recursively as you go into a hierarchy. What a ternary lookup is it's going to take in lots of fields at once and do that all in one clock cycle. So anything today that's an SDN piece of hardware, it's going to be limited because PCAM is probably 50% of the cost inside of a typical switch. So that's a big limitation today. But what vendors are starting to see, and we're starting to see it from Intel and especially some of the foundries are coming out with, taking NPUs and taking general processing and systems on the chips, putting those things together to mirror this at a similar performance. So that's probably what will overcome some of the power and silicon limitation on the board. So the other big thing that changed is the data center. So we have public cloud, we have hyperscale. The famous quote from James Hamilton at Amazon, "The network is in my way." And we are in the way of the business and the customer. There's no doubt about it. If your system guy wants to move his VM and a live workload migration from your data center to your hot data center, you say no, because you can't deliver that at scale. You can't protect the network from melting down on itself. So that's a lot of those use cases today are in production and they're in data centers. So evolution or reinvention. Semantics, but that's kind of where we're going to is proper abstractions is probably the main thing to get to. So the data center, here are just some bullets on some of the things that are the problems in data centers. Probably the main thing is going to be just, particularly applicable to security, is the east-west traffic. So it used to be 95% of the data center traffic would egress out of your data center and either to the internet or to the client-server model. Now it's probably closer to 75% of that is going to be east-west traffic, and 25% of that is actually leaving your data center. So that's a big problem. So the typical hierarchical structure that we build core, we build distribution, we build access, really starts to fall apart there. So that's when we start seeing things like spine and leaf, and we're starting to collapse these architectures down into, and take out some of those layers that will help facilitate that east-west. But even there, what you guys are on the forefront of is how do you apply policy east-west? So if you've got your PCI, either MPLS VPN, or you've got your PCI VLAN, and you've got your front-end DMZ or whatever, do we start carving up these security zones inside a data center? How do you apply policy between those buckets? Typically today, what we do is we run that all north up to a central choke point, and start burning down resources on the policy application side. So we're starting to see a lot of this idea that let's leverage the networking inside of the hypervisor, inside of your VM farm, and start applying policy there. So now instead of that traffic hairpinning up to a policy application point, you're now keeping it inside your hypervisor. So now your east-west traffic is all contained there. So the only purpose for this slide is just to show it's an example using Open vSwitch, but you start hearing this probably more for the more network-focused folks. It's just a regular switch. It's got an associative array pointing from a MAC address to a port. It's got a timer on it that's going to age it out. If it's not there, it's going to flood. So all the same kind of basic concepts. So what happens inside of eSwitch when it does the forwarding? So you've got the same kind of concepts. So you've got to control it. I should put a slide in for this. So networking can basically be broken down into 3 different planes. You've got a management plane. That's where we typically telnet into a box, SSH into a box, and so it's fairly primitive today. You've got a control plane, which is your routing. So anything that is going to maintain topologies of your network and go out and say, well, I had a link go down, I need to update this database. That's going to be your control plane. So just kind of think layer 3, and then layer 2 is going to be your data plane. You take control plane and data plane, kind of put those together, and you wind up with a forwarding plane. But most people use forwarding and data plane interchangeably. So we've got a slow path. Typically, that's going to be some kind of software punt. The first packet's going to go to that. Instantiate a flow down into your slow path, which is your forwarding table. So the nice thing is the first packet comes in, you make a decision based on those headers, and then you instantiate a flow back down, and now all traffic continues to use that particular flow. So it's almost, there's an old Cat 5K MLS, so there are some problems with that. So there's some concern on performance when it comes to that. We'll get into that a little bit later. So just data center overlays. So this is something that's kind of, it's a little confusing, to say the least, when we start talking about overlays. So what we're basically doing is saying, I want to create this abstract network that sits above my physical network. So I don't want to be worried about where this IP prefix is being advertised. I want to have something that sits above that and says it's agnostic to what the underlying substrate is. And so when I do need to move that VM from one side of the data center to the other side of the data center, or data center A to data center B, it's all riding on top of this underlying physical substrate. So this is what our customers want. This is what systems people want. They want one big flat network that isn't in their way. As long as we're constrained by IP addresses, there aren't a whole lot of other options. So as long as the source has to be advertised in one place and that return traffic needs to come back to there, and we don't have any further abstraction, we're stuck with this. So another example of east-west traffic. So security zones, this works, right? So as long as those two, the red and the orange, don't have to interact with each other, whether it's a VLAN, whether it's a VRF, a container VLAN, that east-west traffic is fine. The problem is when you need to apply policy between those two, we're back to the hairpin again. So how do we start thinking about fixing that? Typically the solutions for most things at scale are going to be we push it down, we break it up modularly and push it down closer to the edge. So this also brings more complexity. So I would argue a lot of the data center solutions today are going to bring more complexity to a network. But that's the business need that's driving us in that direction. I think the management abstractions will become better as we kind of continue. So this is what it would look like today. So OpenStack, I don't know if anybody's familiar. So we've got stack wars going on, and it's how do we consume storage, network, and compute into this orchestration and provision from there. So what is happening, that policy is now being applied on that edge at the hypervisor. So the really cool thing that brings us to is the ability to self-provision security. And I think that freaks out security people. It's self-provision, but with that comes APIs and exposures that we can say, I want to audit this is my entire domain security policy, and I can do that because I have hooks into each one of these systems. So this is what it looks like when you spin up a VM on an OpenStack instance, And under the hood, this is just doing IP tables. So if you guys know IP tables, well, I'm probably getting buzzed right now by a bunch of security guys.
Can I ask you a question on that?
Yes, sir.
So, is there any technology right now where you could base this kind of access based on your membership in, say, like an Active Directory group or an LDAP group, to where you could take like individual LDAP or AD-IDs, place them in some kind of maybe a Microsoft group,
Absolutely.
policy, or place them inside of a open source LDAP equivalent, and then say like this, if you're in this role, then you can traverse. I think like on your screen it says like SSH. So like maybe the rule would be if you're in this group, you can use that SSH that's up on the board there.
Yeah. So the question: how do we provision this out of our existing identity management? Keystone is the identity management piece particular to OpenStack. So each of the stacks have their own. So you absolutely have APIs where you're going to go to your LDAP and you're going to pull credentials, and then you can build templates based on that. So it's all very template driven. So you could say anybody from this Active Directory group is going to get this set of permissions, or this, and even further beyond security is this set of permissions, this set of storage, this pile of compute, and so everything that goes along with quotas and that sort of thing.
So you could create essentially like a virtual extranet within your own intranet to like say like a website or something. So you could say like this Active Directory group can get to port 80 on this, what happens to be a web server, for example. And then, so in effect, even though everyone can see the server, only the people that are in the role can actually send packets to the server. So you create like a, I don't want to call it a VLAN, but it's almost like an extranet situation.
Yeah, no, you're exactly right.
And that technology already exists?
Yeah, so
Okay.
So just based on this right here, anything you can do with layer 4 access policy, so that transport piece, or layer 3, obviously source destination IP, you can instantiate into this. So really, if you got anything you can do with IP tables, you can do with OpenStack Quantum mechanism, which is the networking piece of OpenStack. And so that same policy applies to VSG for VMware, and everybody's got their own security thing, but really at the end of the day, the only thing they have that we have exposed to us are these headers. So source destination IP, source destination ports, source destination MAC addresses. So you can really get creative there.
So how does what was the name of that OpenStack authenticator module?
Keystone.
So where does Keystone see, like, say it's Microsoft AD, so where does Keystone see the AD ID, since obviously that's not in a TCP packet, that's not in an IP package, where would that be, like, how would it recognize that, since it's got to be in a higher layer?
Now, are you saying a user logged into it? Because it's not.
Oh, no, like, let's say that, like, you set it up to where an Active Directory group can go to that TCP port 22 there, so they can get to that SSH there. How are those credentials being passed?
Yeah.
Like, how is it seeing that, since that AD ID is not going to be inside of that TCP or IP?
Yeah, exactly. So it would be applied to the group. So so within this, there's multi-tenancy exposed. So you would have a group, let's say for finance. So there'll be an associated ID to that. They log into a self-provisioning portal, and based on their group rights, they're going to have this template default security policy. And they may or may not have this ability to self-provision anymore.
So they go to the portal would say,
Exactly.
okay, Joe, your Mac right this second happens to be 123, and so temporarily it would allow Mac 123 to have access to that SSH for a session, I guess, or a certain amount of time, or
for any time. Well, so I'm sure you could tweak it to be time-based. To be a time-based access.
Yeah, I mean time-based. I mean like more like a session where, like, if they don't send any packets for 30 minutes or something, they would automatically make them go back to the captive portal to re-authenticate. Kind of like almost like websites do, where they have a session, and if you don't do something for a while.
Yeah, and you might be you're getting into cookies and payload at that point.
Yeah. Hey, I just want to know. That's fine.
Yeah, no, that's great. I mean, so to that point, beyond headers is this idea of deep packet inspection.
Yeah.
And we're really not quite there yet, because that's just a hardware limitation.
Yeah.
So, you know,
I'm just thinking if you could move the implementation of your security policy into the networking layer, then you don't have to depend on every individual application to get it right.
yeah,
You know what I'm saying? Because that's where the problem is. You can't scale any of this stuff when every single app has to be perfect. Every single database has to be perfect.
Yeah.
I mean, how are you going to make 200,000 websites and databases perfect if you're a big company?
Well, and how do you do it is through abstraction, right?
Yeah,
You've
I'm
got
just
to
thinking,
have,
well, they all have in common. They've got the network in common. Every last one of them.
right.
And if they don't have it, if they're not on the network, then they're perfectly secure anyway. And if they are on the network, at least we have that in common. So if we could put the security policy on the network, maybe we don't have to make all the apps get it right.
Right.
It'd be like cheaper.
Yeah. And so as a security professional, you guys are, this starts exposing those resources to you guys to start leveraging. Instead of it being this big long list, you know, the 6-month cycle to get something done, because it's got to traverse each of the different departments, or, you know, more accurately, each silo that then sits in somebody's inbox for way too long.
Does this provide support as well for IPsec or VPN tunnels?
Yes. Yes, IPsec is supported in Open vSwitch. And then, so you've got all your encapsulations, CapLab, GRE, those sort of, and STT is a proprietary one that came out of the Sierra, and that'll get sucked into VMware. The difference with that one is it's leveraging ASICs in the NIC to do the encap and de-encap. So there's some interesting, recommend, actually I've got the link on here, so it's in Martin Casada's blog. He's got some pretty cool metrics. So touch real quick on the public cloud. So we hear a lot about it, and you know, I'm sure our business leaders often are coming to us and asking about it. What is it? So the look and feel of what we just showed basically is this network on the left. We've got a firewall that sits in between our VMs, and we can apply any policy there. But what's really happening is what's on the right. We've got a hypervisor there that's acting like a firewall, it's acting like a router. Next gen software, it's going to be acting as a load balancer. So it's really just kind of, not to use a cheesy term, network as a service, but we are kind of headed in that direction. We're probably 5 years late to it. And so the system guys out there are feeling it. And so then if we need to scale beyond just that particular hypervisor, that's where we start. So you could look at this and say, well, this is data center A and this is data center B on the east. Now we just nail up this tunnel between the two. And now we've got that mobility in IP that hasn't really been available to us before, because we're moving this up the stack and we're just using the network as a road. And when you start hearing hybrid cloud, I mean, this is really what it looks like. It looks messy, but you know, we do a lot of this today. So the constraint to it is going to be always the internet. So as fast as the internet is as fast as the public cloud is going to be, because unless you do it at scale, odds are you're not going to be able to nail up a 40 gig circuit between your prim and your cloud provider prim. So, but for some applications that's going to work just fine. And then as we start doing that, the tunnel becomes fairly important, because what that allows us to do is apply the same holistic policy that you're applying in your data center to the cloud. So if you pick up 100 VMs in the cloud somewhere, well, you still need to inspect traffic. You still need to apply your global firewall rules more than likely. So with the ability to tunnel that, you now kind of keep your same policy and keep it same. This is for reading later, but just kind of some thoughts on what the clouds can be. I mean, the biggest constraint is always going to be network. So what that gets in the way of is speeds. I have no faith that our carriers and providers are going to be able to deliver quality enough bandwidth. So enterprise, I'd say probably most of us in here are enterprise, and this is really where it gets kind of interesting. For security, So how do we classify data coming in? Do we classify data coming in with a shim on a machine? What happens when the user brings it from home? It just all falls apart if you're outside of that centralized umbrella. Regulatory is a nightmare. It's either not defined well enough. PCI is probably the only thing I've seen that is defined well enough. That's pretty clear. HIPAA, terrible. FERPA, terrible. Trying to figure out something as simple as whether you're supposed to encrypt over an MPLS circuit that's going over the public infrastructure versus a leased line where it's clear you don't have to. None of that is articulated. So where we tend to land is push as much of that up to the application as possible. You've got SSL, put it in an application. Expect your vendors to write proper applications that support security with it. With that being said, we've got to figure out BYOD. BYOD today is a mess. It's totally unscalable, in band or out of band. You put BYOD in band, you're now creating this bottleneck that you have to life cycle. Every time there's an incremental bump, whether it's 1 gig, 10 gig, 40 gig, 100 gig. The out of band is just as kludgy. 9 times out of 10 is going to be an SNMP push to an edge switch, and we're going to flip a VLAN and try and call that a day. That breaks because you're putting all this intelligence and all this cost on your edge, and you start blowing away your budget. So we do SDN today. It's in wireless. Why does wireless work? Why can't I take a phone, have a call, walk out of this building and walk into another building? Exactly. Because it's decoupled from the substrate. It's probably the easiest way to explain what a data center overlay is because what's happening is you've got a GRE tunnel or a cat-flap tunnel built to your controller. You've got a different address than the underlying network has, and now you can walk from one side of your campus to the other. Can you do that with your VMs today? Probably not. And why can't you do that? Because layer 2 doesn't scale. The internet is not made up of buddy Ivan Petniak, so it's browsers. And it's just funny to hear the guy say West Eastern Bloc guy, but the internet isn't made up of routers. It's made up of routers. Layer 3 scales, layer 2 doesn't. And it's tough to explain that to business because that's what they need. They need to be able to have mobility of an IP and have that IP exist anywhere inside the autonomous domain. So, let me jump back one point here. So the problem that with wireless, perception of the problem with wireless today is it's a central point where you send all traffic to. We're not saying the first packet of a header like we're talking about in an Overblow packet in event. We're sending the entire stream up into a controller and then back down to the user. So what makes this so valuable is we now have complete control over that session. We have complete visibility into all the headers of it, and we can start applying that layer 4 policy saying you can go to this port and not this port based on your identity. So we're matching up identity to policy and executing it in the network.
Brent?
Yes, sir.
I know a lot of people right now are using IPv4 as their, that's the base that everything's set on. So when we move to IPv6 globally, will it help to eliminate a lot of the restraints that you're seeing? Because at that point, then everybody becomes unique at such a level that you can make it go all the way down to the individual, device. And then you could become, it doesn't matter what network you're on, you have that IP address that's you everywhere.
Right. Well, and the only problem is you're still tied to, so somewhere I have to advertise that source address, and it has to have, you can look up in the phone book and say, oh yeah, this address, this IPv6 address belongs to you, and it needs to come all the way back to you. So you're dead on, and that needs to be extracted above, whether it's through some kind of pointer. Something we're writing back with some interns right now is matching that up to names. Use DNS, give me a pointer. I I can point to you you've got a name rather than an IP.
Sure.
But yeah, and then 6, of course, deployment. We might all be retired and maybe dead before that happens.
What?
I know, I'm sorry.
Oh, by 1999.
Right.
That's correct, right?
So how do we scale this hairpin of controllers? Well, we just do it like we scale everything else in this modular. So we break it down into a smaller unit and then stack it out or stack it up. So the idea is that I can't have enough packets per second to be able to support X, Y, Z. I think it's a weak argument because we do it in wireless today. We've got, personally, from 2 years ago, we had 3,000 at any time wireless clients on our 802.11 network. Today we max daily at any one time 30,000. So that's not exponential growth. And why can the wireless absorb that? It's because we can oversubscribe it and because we can apply policy. So the same concept of SDN, which is decoupling the control plane, decoupling the routing pieces of it and the intelligence of where do I send this forwarding entry to, that's what we're talking about here. And so it's there's hardly any difference to it. One's wired and one's not. So what that can lead to is these further layers of abstraction. So networks today they're distributed systems theory problem. So it's how do we maintain state between all of these decoupled routers strewn all over the place. When a link goes down, we flood. I mean, we're still flooding to this day. That's how we exchange state. The database people can probably do this a lot better than firmware running switches. So as we start abstracting that, we then get into that northbound application. So it's a little buzzword, but it's these pieces and parts that you can say, I want this application to manage this resource that's coming in and out of our network. And then the alternative is more of what we do today. So this is when I was talking on, inline doesn't scale. This doesn't scale at all. If you can afford this, you're either your IP is your lifeblood and you have to protect it, your defense, anything else. In most places, you've got your IDS on the edge going out to the internet, or maybe an IDS in front of your data center. What this is interesting for security people is I now can suck in every flow that goes across your enterprise, and you don't have to drink from the fire hose. I can say, well, I just want to see this particular string. Well, that's just a simple match and then an action to fork it off your IDS. So I just threw in some use cases off the top of my head. The first time I was given the deck, so if there's something wrong here, I apologize. It was about 2 a.m. last night. Actually there was something wrong with this. Is saying what we do today, so ignore the SDN-enabled switch A and B. So what we do today is we put something in line that's really expensive, and we, through some kind of proprietary magic in that black box, we can say, well, I want something destined for this particular prefix or this particular port to fork off to my IDS or to my analytics, and I want to consume it that way. That's really expensive. It's all purpose-built hardware. So an easy use case here is, well, I want to use Overblow as an example, and I want to say anything that matches this destination prefix, I want to fork it off to my analytics engine or my IDS, and I want to capture that entire stream. And by the way, I don't want to interrupt any of the traffic, so I'm also going to send it out to ports. So the ability to tap in every device on your network is now this kind of proverbial tap. Matter of fact, for the folks from Indiana, IU's got a pretty cool project that they've actually are implementing this today. Introduction. I just got an email from Matt Davey last night on it that there's a package already out there. So if somebody was interested in looking at this, I'll be happy to shoot them a link. And the other neat thing that it'll do is it can have a cluster of IDSs. So if you're trying to tap into a 40 gig stream, you're not going to be able to pump that into. There's no I/O out there that's going to be able to capture all those terabytes per minute probably. So this is pretty bad. I think this is really cool because you can really just say, I just want to peel this off. And it goes beyond that. So, whether it's a load balancer, when you drain off stuff to one server and you start moving it to another, that same kind of concept is here. So this is what we do today to keep things separate. We've got limited, but there are some virtualization techniques. You've got layer 2 techniques and layer 3 techniques. Whether it's VPNs at layer 3 or whether it's through VLANs at layer 2. And this sort of works. There's a lot of overhead to it. So the problem with it, I know that probably, I'm not sure which of the side you guys are on, but whenever a security guy, architect comes and says, we've got to have this new VRF or this new VPN or this new VLAN, there's no point in starting to segment security unless you're applying policy to each one of those containers. So every time you start growing out these special purpose containers for security, you have to keep in mind that now I have to put a firewall in front of that, and I have to scale that firewall, and I have to life cycle that firewall, and care and feed that firewall. So there's a lot of overhead to that. Managing 4 or 5 firewalls is a nightmare. Some of you guys probably are managing hundreds and even probably thousands of firewalls. So they're all distributed, they're all standalone, one doesn't know about the other. So more than anything, I think what SDN represents is coherency to operationalizing networks. So we're decoupling these applications from the substrate. So if my switch is just this canvas that I want to apply application to, well, I now start doing applications north of that and instantiating those applications down into the switch. So whether that's analytics, whether that's inspection, load balancing, all these things are happening today to some degree in VM farms, and I think it'll just continue to keep growing because these are big data problems. There's probably no more data that could be collected in any of our networks than the network data itself. A typical NMS is probably doing more transactions in a database than any other system in your entire network. And that's all we're looking at is a pretty small set of things. If anybody's able to collect all their flows in their network, I'm impressed. Tell me how to do it without breaking the bank and your budget. So I think that ability to take more fine-grained approaches to those flows and consuming that data begins to give you this predictive analysis where it's somebody's fuzzing you and you can now start correlating that all over the network. So it's all that flow data being exposed is just going away. So and this is just kind of a example of what is possible today. None of that's readable. So just using the Floodlight Overflow controller, we're writing just a simple little module to plug into probably less than 1,000 lines of code. But what it allows us to do is classify at the edge. So the idea to decouple IP from the underlying network is easy to say, but I'm still constrained to another IP on top of that, right? So we've got names today. We've got DNS. They don't typically mean a whole lot out of Active Directory. They're very important inside of Active Directory. Why aren't they important to the network? So if you're a systems guy and you're deploying a new DMZ box, you're calling up the network guy and saying, hey, I need to get you to provision a DMZ VLAN, and 3 weeks later that may or may not get done. It'd be pretty cool if you could just say, well, I'm going to use the DMZ subdomain, and now that's getting recognized, and I'm provisioned into that security context. And it's as simple, this isn't like a startup pitch or anything. This is just, all I want a router to do is to be able to be aware of a DNS name. And it's as simple as that packet comes in, it does a lookup in cache, matches that to a policy, and then those flows corresponding from it. It's bizarre how easy it is to come up with new applications when we start thinking about it, because we've never been able to do that before. So we're just, we've been told, here's how we do networks, this is how you scale them. Again, I think the security firm is probably the most interesting of any of it. So you can take that beyond security and start saying, well, now I want my MPLS traffic engineering path to go here. I want an LSP to go this way based on how I classified my traffic on the edge. Because classification, SDN isn't fixing classification. How do you guys identify what traffic and who it is coming onto your network? It's a hard thing, and BYOD is obviously destroying that. And the Dilbert slide on the first is a great example. I need to be able to work wherever I need to work. IT needs to get out of the way of business because we're here to serve the business. So if anybody's interested in just kind of getting their feet wet a little bit, so there's a lot of talk, and it's the hype almost exhausts people on what exactly is this and how do you do this. It's really easy. We know how to build hybrid networks. We know how to isolate traffic. We've got VLANs, we've got MPLS, we've got virtualization techniques today. So you can literally take a switch that has an Overblow agent on it, say everything else on this switch except for this one particular VLAN is going to be native legacy protocols. On this one VLAN, I want to say this is going to be OpenFlow enabled. So this is the VLAN you could say I'm going to fork off traffic going to this particular IP prefix or any traffic coming in with port 80, and I can take that and now I have this granular control over it. The applications aren't there yet, so if you're doing any of this, brush off the Python or the Java. But the cool thing is there's libraries for it. So if you go back and take a network engineering bachelor's or master's or PhD for the past decade, you're learning protocols. I really don't care about a particular TLD in the ISIS protocol. That should be a library. I should be able to call out in a method and do it. And if I need some particular tweaks in it, well, that should be a drag and that should be a click and go. So another better picture, a little larger, but so you would just hang off a x86 box, you would attach it to your switch, and then enable that on one of your VLANs, and you are doing SDN. And you can also do learning, so you can have it operate just as a typical switch. So it'll still do flooding, it'll still do all the traditional concepts. Where it is completely undefined for the most part today is where, and this is, it took me a while to kind of get my head around this after 15 years of staring at traditional networking, which where do we redistribute this SDN island into a normal legacy backbone, whether it's MPLS or just IP IGPs, and then attach it to another island. So there has to be some layer 3 redistribution. So I'm advertising an address from here, somehow that needs to get to here. So there again, it's probably just going to be some kind of library call that says I need to pull up OSPF, I need to build an adjacency to my core network, and I need to redistribute those prefixes back down into the And while I'm at it, I'm going to start applying my holistic policy, whether it's security, whether it's quality service, whether it's traffic engineering. I'm going to mark those packets to do the appropriate action. Little unicorn fighting my dinosaur. So this is just on scale. Right? We know how to scale networks. Again, we scale everything modularly. So when does it happen? Starting to. So there's startups around this. There's really good open source packaging projects out there that you can start kind of learning some of these concepts. I mean, I don't do this for a living. I do this at home at night. I'm a loser, but some people are. There's a lot of product managers out there that are working really hard to deliver applications that we can make our lives easier as opposed to doing. And so if you think 10 years ago when a VM farm came around, everybody thought they were going to lose their job. Like, all the systems people were like, this is crazy. I'm going from 1,000 standalone servers and I'm flopping floppies and bays and now you want me to put it all in one tier, I'm going to lose my job. Well, there's a hell of a lot more systems administrators today than there were 10 years ago. And what those folks are now able to do is focus on how do I capacity plan, how do I make sure I'm going to have enough storage to meet growth, how do I have enough compute to meet growth. So it's the same concepts here. If anything, it's going to explode the networking industry because we're actually going to be a lot more useful than just plumbers, because that's about all I am today. Something gets clogged, we fix it, and maybe add another pipe into it. So here are just some links. There's so much information. There's some just really good thought leaders that I interact with as much as possible to try and learn what's going on with it, and more importantly, I think really getting to know what the use cases are, and what is it that your systems people need, what is it your security people need. I think this is a chance for us to kind of evolve into the ecosystem of IT instead of just kind of being the island. Because security is, I tend to lump with network. We're just kind of out here, and something breaks, it breaks, and then it's our fault. So, yeah, so we're just renaming things to some degree. This is might be ATM all over again. I'm not sure yet. Any questions? Again, this is all out there. Feel free to contact me. I'll give you a login on some boxes if you want to tinker around. Yes, sir.
So most of the equipment people are planning to sell, like the switches that also have, like say, open flow capability or whatnot, by themselves, they'll also act as a normal switch. Because I'm thinking, so some people go, I don't want to configure all this. I just want to plug it into a simple network and just have it be like it always was. But most of these devices will fall back to that, and then if you wanted to get real specific, like, okay, this IP has this DNS name, so I know I can route it this way, you can.
No, it's a great point. So the hybrid, so are we going to be getting gear that supports hybrid SDN and native legacy protocols? Absolutely. Every vendor out there, I mean, there's a couple like, Pronto, it would be one where it's you get a firmware and you attach and that's it. But everybody else is going down the hybrid path. Some people want just firmware because I think personally I need to be able to operate a network before anything else. So if we can start building these pockets and if we can virtualize our existing infrastructure to start supporting this, and I would think a roadmap would be, you've got legacy, you build up something to the side, whether it's logically or whether it's physically, and then you start migrating more into that as the use cases and applications develop. So you've got, there isn't really a vendor out there that's not committed to doing this, at least in word. Obviously, if you're an incumbent right now, this is probably as disruptive as they've ever seen since Ethernet. So there'll be some shift there. But I think everybody sees that, and they're not gonna, they're smart enough and their stockholders are savvy enough to say, we need to get ahead of this. And so it's either going to be, we're going to hear a lot of, well, here's our development kit, here's the libraries, I want you to attach to it, and I think that's okay. I think just having that ability and exposing those network elements, whether in a proprietary fashion or in a proprietary API or in an open source API, but I think if we go back in the history of x86, I think the history of going from, I think OpenStack's probably a pretty good clue into our future, in my opinion. So VMware is probably a little worried about something like OpenStack because it's taking, it's commoditizing kind of that value. So, but I think just the customer demand, I owe my allegiance to Google because when they ask for something to get it, they're typically like at least 2 years ahead of the curve in most areas of compute internally. So when they ask for it, we can get it. And so I think